Okay, Assalamualaikum. So today we're going to learn about speed control of induction motor. Okay, so the speed of induction motor is changed from both stator and rotor side. Okay, meaning that we can control our speed. Okay, control the speed of induction motor. Okay, from stator and rotor side. Okay, we have stator and rotor side. Okay, so the speed control of three-phase induction motor, okay, from stator side are further classified as, okay, we have four method. Okay, the first method is VF ratio, or we call VF control or frequency control. Okay, and then the second method is changing the number of stator pole. Okay, and then the next one is controlling supply voltage, and lastly adding rheostat in the stator circuit. Okay, so the second method, which is changing the number of stator pole. Okay, for this syllabus we just cover in term of theoretical. Okay, but another three methods. Okay, VF ratio, controlling supply voltage, and adding rheostat in the stator circuit. There will be calculation involved. Right. So for stator side, okay, from stator side, okay, control the speed of AC motor from stator side, which is frequency control. Okay, so since the synchronized speed is directly proportional to the frequency, okay, remember the equation is 120 F, okay, and NS, okay, equals to 120 F over P. Okay, so the speed, okay, the synchronized speed can be varied if we vary the frequency. So when the frequency is larger, so NS will be increased. Okay, when we increase the frequency, okay, the synchronized speed will also be increased. Okay, however, the main disadvantage of this method, okay, the supply frequency is usually fixed. Okay, varying the supply frequency required expensive power electronic supply. Okay, we know that in our country, okay, the frequency supply is 50 Hz. Okay, so that is fixed, okay, from the TNB. So if we need to change our frequency, okay, we have to add another external circuit, okay, which is we use power electronic equipment. Okay, so three basic type of variable frequency supply. Okay, variable frequency motor alternator set, okay, DC link inverter, converter inverter, okay, and then cyclo converter. So this is the three types of power electronic equipment. Okay, and the circuit that we going to use for varies the frequency. Right, so converter inverter circuit arrangement for variable frequency and voltage, supply from constant V and F. Okay, so it mentioned that arrangement for variable V, F, supply from constant voltage and frequency supply. Okay, so let's look at this type of connection, okay, or this type of circuit. Okay, we have AC variable, okay, which is voltage and frequency is fixed. Okay, from the supply, okay, the frequency and voltage is fixed. Okay, so next, okay, so we need to change or to vary our frequency. So we use converter. Okay, so converter, okay, the function for converter is to convert, okay, from AC to DC. Okay, so this is rectifier. Okay, so the converter used here is rectifier. Okay, to convert AC variable to DC variable. Right, so from AC it will be converted to DC. So instead, so it will become voltage and frequency variable. So instead of fixed, it will be it can be varies, okay, in terms of voltage and frequency. And because of induction motor is use AC supply, so we need to convert back our DC variable, okay, into AC variable. Okay, so the purpose this circuit is, okay, from voltage and frequency fixed, okay, we need to change in term of variable, voltage and frequency variable, so we can vary the frequency lah. Right, so we use inverter. So from DC to AC we going to use inverter. Inverter will be used. Okay, so we can change the voltage and frequency in terms of variable. Okay, so this is the formula, okay, used to analyze the method for frequency control. Okay, T max, okay, which is our maximum frequency. Okay, you can write this formula and you can see this formula. Okay, so this T max is used for frequency above rated. Usually our rated frequency is 50 Hz. Okay, so when the frequency is more than rated, okay, above rated, for example 100 Hz, okay, so the maximum torque, the equation for maximum torque is used this one. Okay, and then for frequency below rated, okay, the equation for T max is this one lah. Okay, so the difference between this formula is the alpha. Okay, so this one is divided by alpha, this one is multiply alpha. Okay, and the rest is similar. Okay, so what is alpha? Alpha is supply frequency divided by base frequency. Okay, supply is our rated frequency, okay, divided by base. Okay, base frequency is actually the our variable frequency. Okay, and then another one is the equation for T rated over Tx, okay, which is K over alpha, in bracket square equals to T rated over Tx. So to determine the voltage frequency ratio, okay, so this one we call VF ratio, K multiplied by V rated divided by Fx. So Fx is our variable frequency. Okay, so K is the constant that we get from this equation. Okay, so VF ratio is given by K multiplied by V rated divided by Fx. So we call this one is VF ratio. Okay, and then another important formula is starting torque. Okay, so you can see the formula for starting torque is 3V phase squared divided by omega s, okay, multiplied by alpha, okay, divided by R1 squared plus alpha squared multiplied by S1 plus S prime 2 squared. And then for starting current, okay, alpha multiplied by V phase, okay, divided by R1 squared plus alpha squared multiplied by S1 plus S prime 2 squared. Okay, so this is the formula used for VF ratio. So you have to know the formula lah. Okay, so this is another in term of circuit topologies. Okay, we have supply rectifier that convert from AC to DC. Okay, and then we have the inverter that convert back, okay, from DC supply to AC supply, okay, because of our motor is AC, so that's why we have to convert, okay, from DC to AC. Okay, so the purpose is we want the varies frequency, okay, the frequency that can be varied, okay, because of from the supply, okay, the voltage and frequency is fixed, so we need to convert this parameter first in term of DC, and then convert back in term of inverter, in term of AC, so that we can control the voltage and frequency. Okay, so the second method is pole changing method. Okay, back to our equation here. Okay, so the speed, okay, can be varied by varies frequency, and then another one is by varies the pole. Okay, the pole is our the number of poles, the number of poles. So in pole changing method, the speed is varied by effectively changing the number of poles. Okay, the change of pole is achieved by designing the stator winding such that the connection to the various coils, the terminal of which are brought out, can be changed. Okay, however, the poles can be changed in a fixed ratio. Okay, for example, if the poles are changed by 2 with ratio to 1, it will result in twice synchronized speed. Okay, only discrete changes of speed can be achieved by this technique. Okay, a number of independent windings are needed to achieve different synchronized speed. Okay, however, due to the size of the slot, the number of independent windings that can be placed in the slot of stator are limited. Okay, so sorry. So the next method is by controlling supply voltage. Okay, this method is simple and economic, but the motor losses increase with increase in slip. Okay, so remember, slip is the difference, the speed difference between S and R. Okay, this method is rarely used because of a small change in speed required a large reduction in voltage, and hence the current drawn by motor increase. So remember, if the voltage is low, okay, the current is higher, okay, which cause overheating of the induction motor. So overheating is because of the increasing of the current. So it will make the our coil is overheating. Okay, achieved by using anti-parallel thyristor. Okay, so remember, thyristor is the diode that we can control the firing angle. Okay, controlling supply voltage. Okay, AC voltage controller using anti-parallel thyristor for speed control of induction motor. Okay, so why it mention anti-parallel? So because of we connect, okay, the thyristor in different way. So the thyristor, okay, is connected this way, and another is connected this way. So it called anti-parallel. So the connection is parallel, but the direction is different. Okay, so this is the practical connection of AC voltage controller. Okay, A is the delta connected controller. So each side of winding is connected with anti-parallel thyristor. Right, so the next method is by changing we add external resistor on rotor side. So on previous part, I explained the speed control of induction motor by okay, varies on stator side. Okay, but for this one is based on rotor side. Okay, so the only method that we going to cover is adding external resistance on rotor side. But there is another method which is cascade control method, and then injecting slip frequency EMF into rotor side. So we just cover on the first method, okay, adding external on rotor side. Okay, so adding rotor resistance can be achieved by employing variable resistance in the rotor circuit. Okay, this type of speed control is only possible for slip ring induction motor. Okay, so this is the type of induction motor which is slip ring. Another one is squirrel cage induction motor. Okay, for this type of motor method is suitable for slip ring induction motor. Okay, maximum value of torque does not depend on the value of rotor resistance, but the rotor resistance influences the slip at which maximum torque occurs. Okay, the slip is increased by increasing the value of stator resistance. Okay, so remember slip is the different speed between synchronous and rotor speed. Okay, so this is the diagram, okay, for adding rotor resistance adding resistance at rotor side. Okay, we add external resistance in series with each terminal RY and B. Okay, so this is another method, okay, still adding rotor resistance, but by using chopper resistance. Okay, chopper is another type of converter which is convert DC to DC. Okay, so in summary, okay, for speed control of induction motor, from stator side we have VF ratio or frequency control, and then controlling supply voltage. Okay, so I just summary on the method that we going to discuss on calculation. Okay, VF ratio, supply controlling supply voltage, and then from rotor side is by adding external resistance on rotor side. Right, so thank you.